Hello, this is Mrs. Boots, and we're going to work the practice problems for compound interest. Remember, with compound interest, you're using the equation y equals a, parenthesis, 1 plus r divided by n raised to the nt power. So let's figure out what we've got. If $500 invested at a 6% interest rate compounded quarterly, what's the balance after 3 years? From this statement, I know that A is 600. Nope, A is 500. R is 6%, which is going to be a 0.06. N, compounded quarterly, is 4, and T after 3 years. So let's plug that in. Y equals 500, parenthesis, 1 plus R, 0.06, divided by 4, raised to the power of 4 times 3. I plug that all in the calculator, and I get Y equals, remember this is money, so we need a dollar sign, and we're going to round to the nearest penny, $597.81. Number 2. $2,000 is invested at 7% annual interest compounded monthly. What's the balance after 5 years? So I start with 2,000. That's my A. The 7% written as a decimal is 0.07. Compounded monthly, there's 12 months in a year. That's my N. And the balance after 5 years, that gives me T. So I'm looking for Y. Let's plug it into the equation. Y equals 2,000, parenthesis, 1 plus 0.07 divided by 12, close the parenthesis, raised to the 12 times 5 power. Plug it into the calculator, and you get $2,835.25. Number 3. Find the value of $1,000 deposited for 8 years in an account paying 8% interest compounded semi-annually. Okay, if it's deposited, that's the amount I started with. So the 1,000 is the A value. 8 years is my time. It's paying 8%, so R is 0.08. And it's compounded semi-annually. That's every 6 months. That happens twice a year. I'm looking for Y. So let's plug it in. Y equals 1,000, parenthesis, 1 plus 0.08 divided by 2, close the parenthesis, raised to the 8 times 2 power. Yes, I know 8 times 2 is 16, and you could go ahead and plug it into the calculator that way. So once we plug it in, we get $1,872.98. Remember to round to the penny. Number 4. How much money must be deposited in an account that pays 9% interest compounded monthly to have a balance of $1,000 after 3 years? How much money is deposited? That tells me I'm looking for A. The account pays 9%, so I've got 0.09 for my R. Compounded monthly means 12, because there's 12 months in a year. The balance is 1,000 after 3 years. So 1,000 is Y and 3 is T. Now let's plug it in. I wouldn't have Y equals, I would have 1,000 equals. A parenthesis 1 plus 0.09 divided by 12 raised to the 12 times 3 power. Okay, remember that this whole big stuff in parentheses raised to a power is actually a number. We can compute that part in the calculator. So what do we get when we compute that number? I got 1.3086. Okay, so that's the coefficient for A. To get rid of it, we're just going to divide both sides by 1.3086. And we get the value of A, which is $764.15. Remember, if you rounded it differently, you're going to get something slightly higher, slightly lower by a couple of dollars. Number 5. How much money must be deposited in an account that pays 7% annual interest, compounded quarterly, to have a balance of $4,000 after 5 years? So A is what I'm looking for. 7% turns into 0.07. Compounded quarterly, there's 4 quarters in a year, so N is 4. My time is 5 years, and they want me to have the 4,000 in that 5 years. Now let's plug it into the equation. 4,000 equals A, parenthesis, 1 plus 0.07 divided by 4, raised to the 4 times 5 power. Remember that this parenthesis part can be simplified. So let's enter just the parenthesis part in the calculator and get a number for that. I get 1.415. Okay, so now we can divide both sides by the 1.415, which is a coefficient of the letter A, and we would get the value of A, which is $2,827.30. Number 6. How much money must be deposited in an account paying 7% interest compounded yearly to have a balance of $10,000 after 6 years? So again, I'm looking for what we started with. I want to end with $10,000 after 6 years. My rate is again 7%, but this one's compounded yearly, so it simplifies a lot because that's like a birthday. It's just once a year. So now let's plug it into the equation. Y equals, so I have 10,000 equals A, parenthesis, 1 plus R, 0.07, divided by 1, which you don't really have to put that part in, raised to the 6th power. Now, simplify the big parenthesis part. So I have 10,000 equals A times what? Well, that would be 1.5. That's a pretty good return. So we're going to divide both sides by the 1.5 coefficient. When we divide, we find the value of A, which is $6,663.42. That was the beginning balance in order to get $10,000 after 6 years. Number 7. How much money must be deposited in an account paying 5.25% annual interest, compounded monthly, to have a balance of $12,000 after 8 years? Okay, again we're looking for the deposited amount. My interest rate, it doesn't matter that there's already a decimal. I just move it 2 places to the left. So the interest rate becomes 0.0525. N is 12, T is 8. That's the easy part. Now let's plug it all in. 12,000 equals to A, parenthesis, 1 plus 0.0525 divided by 12, raised to the 12 times 8 power. Remember, we're going to plug that into the calculator. That big old parenthesis part, just the parenthesis part, and get a value for it. I get 1.5203. Divide both sides by the 1.5203 to find your A value, which was the deposited amount. Remember, this is in dollars, US dollars. I get $7,891.79. Number 8. How much money must be deposited in an account paying 4.3% interest compounded daily? How many days are in a year? Yeah, 365. To have a balance of $20,000 after 9 years. Okay, so I'm looking for A again. 20,000 is my Y, 9 is my T. We've already discussed the R and the N. So let's plug it in. 20,000 equals A times parenthesis of 1 plus 0.043 divided by 365 raised to the 365 times 9 power. That's a lot, but that's okay. The calculator can handle it. Remember, we're just putting that second box, the parenthesis part, into the calculator, get one number for it. So 20,000 equals to A times what? I get 1.47. Okay, divide both sides by 1.47. So 20,000 divided by 1.47 would give me $13,582.13. That's what I would have had to have started with in order to get to $20,000. This concludes our practice for compound interest.